is a place at the very edge of what we can imagine. Not the edge of space. Space has no edge. It goes on and on and on in ways that quietly unseat the mind. The edge of what we can ever reach. The edge of what light itself has had enough time to cross since the moment the universe began. Beyond it is territory that exists, that has always existed, that we will never, ever see. And right there, on the absolute frontier of the observable universe, at the furthest point any human instrument has ever looked, sits a galaxy. It formed when the universe was not even a toddler, when the first stars were barely learning to burn, when the darkness was only just beginning to break. It is not the biggest, it is not the brightest by the standards of what came after. It is not home to anything we know of, but it is the farthest, the most ancient structure humanity has ever confirmed with certainty. A galaxy whose light has been crossing the universe for 13.5 billion years and only just arrived here, now, in our instruments, in our time. Its name is MoM-z14, and the story of how we found it and what it means that it even exists is more unsettling, more beautiful, and more strange than almost anything else in the history of astronomy. This is the story of the most distant existing place in the known universe. Before we go there, we need to understand what we're even saying when we say most distant. Because the universe doesn't work the way distance usually works. When you drive 100 miles, those 100 miles stay 100 miles. The road doesn't stretch while you travel it. The destination doesn't move. Space does. Space itself is expanding. Every point in the universe is moving away from every other point. Not because galaxies are flying through space, but because space itself is growing between them, like dots drawn on a balloon as it inflates. The dots aren't moving across the surface. The surface is getting bigger and the dots ride with it. This has a consequence that is deeply strange. The light from MoM-z14 has been traveling toward us for 13.53 billion years. But while it was traveling, the universe was expanding beneath it. The very space it was crossing kept stretching. So the place it came from kept moving away. By the time that light finally reaches us today, the galaxy it came from is no longer where it started. It is now approximately 33.8 billion light-years away from Earth. Not 13.5 billion, 33.8 billion. And it will be even farther by tomorrow. This is not a contradiction. It's just how a universe that never stops growing behaves. And it means that the distance to MoM-z14 isn't really a distance in any sense we intuitively understand. It's more like the length of a path taken through a landscape that was folding outward the entire time. When you look at MoM-z14, you are not seeing MoM-z14. You are seeing a ghost. The light that reaches us from it today left that galaxy 13.53 billion years ago. The galaxy we observe is the galaxy as it existed in the deep past, during a time when the universe itself was barely 280 million years old. Less than 2% of its current age. Think about that in human terms. The universe today is 13.8 billion years old. If you compress the entire history of the universe into one human lifetime of 80 years, then MoM-z14's light left when the universe was approximately 6 months old. We are not seeing that galaxy now. We are seeing it then. And this is true of everything we observe. The moon, as it was 1.3 seconds ago. The sun, as it was 8 minutes ago, the nearest star as it was 4 years ago, the Andromeda Galaxy as it was 2.5 million years ago. The farther away something is, the deeper into the past we're looking. MoM-z14 is so far that we're looking all the way back to the first chapter of the universe. And here's what makes it stranger still. Because the universe has expanded so much since then, the light that left MoM-z14 has been stretched. Wavelengths that once vibrated as ultraviolet light, the kind our eyes could never see, have been pulled outward by the expansion of space until they arrive at Earth as infrared radiation. Invisible to human eyes, but not invisible to the right instrument. Astronomers measure this stretching as redshift. The larger the redshift number, the more the light has been stretched, and therefore, the farther and earlier the source. MoM-z14 has a redshift of Z equals 14.44 round, the highest ever spectroscopically confirmed for a galaxy, a number that marks it definitively and precisely as the single most distant known object in the universe. But here is the thing that no one tells you when they talk about distant galaxies. MoM-z14 is not at the edge of the universe. It is at the edge of the observable universe. These are not the same thing. The observable universe is not a wall. It's not a boundary where space stops. It is the limit of what light has had time to reach us from, given the universe's age. Light moves at a fixed speed. The universe is 13.8 billion years old. So light from sources more than a certain distance away simply hasn't had time to get here yet. Beyond the observable universe, space continues. Galaxies exist, stars burn and die, and leave their remnants behind. Entire cosmic civilizations, if any exist, may be going about their existence right now, completely beyond our ability to ever know about them. Not because the universe hides them, but because the universe is too big and too young for the speed of light to have bridged the gap. And here is the part that truly humbles. The observable universe has a radius of about 46 billion light-years in every direction. That's a sphere of space we can see. But because the universe appears to be infinite, or at minimum vast beyond any number we can meaningfully work with, the observable universe may be only a tiny fraction of everything that actually exists. Like standing in a small circle of lamplight in the middle of a continent at midnight and calling the circle of light the world. MoM-z14 is right at the very edge of that lamplight. Just beyond it is everything we will never see. It didn't happen suddenly. The discovery of MoM-z14 is the end of a decades-long journey, each step pushing the frontier a little further back in cosmic time. For most of the 20th century, the most distant things humanity could see were quasars, the blazing hearts of young galaxies, and they pushed our vision only so far. The instruments weren't there. The technology wasn't there. Then came the Hubble Space Telescope. In 1995, Hubble stared at a seemingly empty patch of sky for 10 consecutive days. It returned an image of approximately 3,000 galaxies, some of them so distant they were seen as they existed when the universe was less than 1 billion years old. It changed everything. But Hubble had limits. Its mirrors were designed to see mostly visible light. The most distant galaxies, their light stretched into infrared by the universe's expansion, were beyond its reach. Hubble's greatest distance record was a galaxy called GN-Z11, confirmed in 2016. It had a redshift of Z equals 10.957, making it visible as it appeared roughly 400 million years after the Big Bang. At the time, it was the most distant galaxy ever confirmed. Astronomers celebrated, and then they waited after Euro, because everyone knew that to go further, to push deeper, to see the real edge of the first stars and galaxies, they would need something else entirely. They would need a telescope that could see in infrared. A telescope with a mirror not the size of a car, but the size of a room. They would need James Webb. The James Webb Space Telescope launched on Christmas Day, 2021. But it took 6 months of careful unfolding, aligning, and calibrating before its golden eye was ready to look. Its primary mirror stretches 6.5 meters across a Euro, nearly 3 times the diameter of Hubble's. It is coated in gold, chosen because gold reflects infrared light better than any other material, and it operates not in Earth's orbit, but 1.5 million kilometers away, at a gravitational balance point called L2, where it can keep the Earth, Moon, and Sun all behind its sunshield at once, shielded from their warmth, cooled to temperatures close to absolute zero, quiet enough to detect the faintest infrared whispers from the earliest universe. Within its first year, Webb broke the distance record not once, but repeatedly. One discovery after another pushed the confirmed frontier deeper and deeper into cosmic time. Glass ZZZ, Seed Z, Seed Z, 0. Jade's GSZ 14-0. Each one farther than the last, each one revealing a universe that looked nothing like the models predicted. Because here is what astronomers expected to find when they looked at the very early universe. They expected small, dim, primitive galaxies, barely more than loose collections of the very first stars, still assembling themselves from gas and dark matter. Faint, rare, sparse. What Webb showed them was something else entirely. Galaxies at redshifts beyond 10 euros, existing less than 500 million years after the Big Bang, were not dim, they were luminous, strikingly luminous, and they weren't rare. They were showing up in survey after survey, far more often than any theoretical model had predicted. Something was wrong, or something was being learned. Nobody was quite sure which. By early 2025, a team of astronomers had noticed something in the deep Webb imaging data, a bright, compact object in the Cosmos Webb survey field, a massive, coordinated effort to image hundreds of square arc-minutes of sky in extraordinary depth. The object disappeared completely at shorter wavelengths. Blue light, gone. Near ultraviolet, gone. But in longer wavelength infrared filters, it glowed, persistently, unusually brightly. This is the classic signature of an extremely distant galaxy. When a galaxy is far enough away, its ultraviolet light, emitted by hot, young stars, gets absorbed by intervening hydrogen gas before it ever reaches us. The galaxy vanishes in short wavelengths and only appears in longer ones. Astronomers call the cutoff point a Lyman break. The farther the galaxy, the further along the spectrum the break appears. This object's break appeared at wavelengths consistent with a redshift above 10, possibly well above 10. So the team designed a survey specifically to follow up on objects like this. They called it the Mirage or Miracle Survey. The name was deliberate and honest, because when you find an object that seems impossibly bright, impossibly early, impossibly large for its supposed age, the first question you have to ask is this real, or is it something else? A galaxy much closer that simply looks similar. Dust, emission, unusual star formation in a nearer galaxy can sometimes mimic the appearance of a very high redshift source. These mirages have fooled astronomers before, so they turned Webb's near-spec instrument, one of the most sensitive spectrographs ever built, onto this candidate. For nearly 10 hours, they collected its light, spreading it across a spectrum, looking not just for the brightness, but for the fingerprints. And in April 2025, the answer came back. A spectroscopic redshift of Z equals 14.44. Not a photometric estimate, not a guess derived from which filters the light appeared in. A confirmed, precise, peer-reviewed redshift measured from actual emission lines in the galaxy's spectrum, as unambiguous as a fingerprint. MoM-z14 was real, and it was the most distant galaxy ever confirmed by human instruments. Its light left before the Milky Way existed, before the Sun existed, before the Earth existed, before most of the atoms in your body had even been forged inside dying stars. The number 14.44 feels small. It doesn't announce itself, but what it represents is staggering. At a redshift of 14.44, we are seeing MoM-z14 as it appeared 280 million years after the Big Bang, at a time when the universe was 97.8% younger than it is today, when the first generation of stars was only just igniting in the primordial gas, breaking hundreds of millions of years of cosmic darkness. The confirmation was published in the Open Journal of Astrophysics on January 28, 2026. The lead author, Rohan Naidu of MIT, called it exactly what the survey name implied. Not a mirage, a miracle. Now, what is MoM-z14 actually like? Because it is not what anyone would have pictured. It is extraordinarily compact. If the Milky Way were a city, MoM-z14 would be a single city block, an effective radius of only about 241 light-years across. The entire Milky Way stretches roughly 100,000 light-years from edge to edge. MoM-z14 fits inside something 1/100th of that width. And yet in that impossibly tiny volume, it blazes. It is more than 100 times brighter than models predicted a galaxy of its age should be. Not a little brighter, not slightly anomalous. 100 times. The kind of discrepancy that doesn't just tweak theories, it upends them. Part of this brightness comes from its star formation rate. MoM-z14 isn't gently building stars over billions of years, the way mature galaxies do. It is erupting with them. Its star formation rate appears to have increased by a factor of 10 in just the last 5 million years before the moment we're seeing it. 5 million years being an eye blink on cosmic timescales. A sudden, violent burst of creation happening at the farthest edge of what we can see. It is also almost completely dust-free. In mature galaxies, stellar dust builds up over time, absorbing light, reddening it, dimming it. MoM-z14 has almost none. Its stellar population is young and pristine, burning with the full, unobscured light of its first stars, not yet dulled by the debris of the stars that came before. And then there is the nitrogen. When astronomers spread MoM-z14's light across the spectrograph, they found something unexpected even beyond its distance. Nitrogen emission, and not just a trace. MoM-z14 has an unusually high ratio of nitrogen to carbon, a ratio that, in the modern universe, is typically associated with one specific type of ancient stellar relic: globular clusters. Dense, compact balls of some of the oldest stars in any galaxy, forged in the most extreme star-forming environments that ever existed. The chemical signature of MoM-z14 hints that it may have hosted a type of star we have never directly observed, hypothetical objects called supermassive stars. Not supermassive black holes, actual stars. Objects theorized to reach masses of 10,000 solar masses or more. Objects so extreme, so violently short-lived, that they would live for only a few million years before collapsing into black holes. But in those few million years, they would forge heavy elements at a pace that normal stars can't match. There are no supermassive stars in the universe today. They belonged to the very first generation, the stars that existed before the stars. If MoM-z14's nitrogen enrichment is evidence of them, we may be seeing the chemical signature of the most extreme stellar objects that ever existed, still written in the spectrum of the galaxy they left behind. A fossil of the very first stars, preserved in the light of the most distant galaxy we've ever found. Here is what makes MoM-z14 more than a distance record. It is part of a pattern. Before JUICE launched, the theoretical models of early universe galaxy formation had been built up over decades. They predicted that the very first galaxies would be small, dim, and rare. The process of building a galaxy was supposed to be slow and dark matter pulling gas together over hundreds of millions of years, gradually forming stars, gradually growing. Webb found the opposite. Survey after survey, early galaxy after early galaxy, the picture that emerges is of a universe that got to work immediately. Galaxies that are too bright, too massive, too chemically evolved, too structured, too many of them. The number density of bright galaxies at redshifts above 10, implied by the Mirage or Miracle survey, is more than 100 times larger than pre-Webb models predicted. Not 10% higher, not twice as many, 100 times more than expected. This is not a small adjustment to the models. This is a fundamental problem. Either the models are wrong, or we are missing something important about the physics of the early universe. Perhaps the way dark matter clusters, or the efficiency with which gas collapses into stars, or some feedback process we haven't accounted for. Some astronomers have suggested that dark matter itself may behave differently at early times than our models assume. Others have proposed that the first stars were simply far more efficient at producing light, burning brighter and hotter per unit of mass than stars today. Still others wonder whether some of what Webb is seeing as starlight is actually the glow of accreting black holes. Black holes that formed from the very first stellar collapses and began feeding immediately. Nobody knows yet, and that is precisely what makes this moment in astronomy so extraordinary. MoM-z14 doesn't just break a distance record. It breaks a comfortable picture of how the universe works and demands a new one. MoM-z14's hold on its title is almost certainly temporary. The same tools that found it are still running. Webb continues to stare into the deep universe, accumulating data from surveys designed specifically to find what lies beyond the current frontier. And a new instrument is joining the search. The Nancy Grace Roman Space Telescope, NASA's next great observatory, is designed to survey vast swaths of sky in infrared with a field of view 100 times larger than Webb's. Where Webb sees one small patch in extraordinary depth, Roman can map enormous regions quickly, flagging candidates for follow-up confirmation. The two telescopes together form a system more powerful than either alone. And the physics tells us there is more to find. At redshifts of 15, 16, 20 and beyond, in the era of the very first stars, before any recognizable galaxy existed, there is a frontier that no confirmed observation has yet reached. The era of population 3 stars. The very first generation, born from pure hydrogen and helium, leaving no direct record except in the chemical signatures of what came after. We have never seen one directly, but if any relic of their existence is embedded in an early galaxy's spectrum, we now have the tools to look. The edge is not fixed. It has been moving outward our entire scientific history, from the nearest planets, to nearby stars, to the Milky Way, to nearby galaxies, to the cosmic web, to the most ancient structures in the observable universe. MoM-z14 is simply the latest step. It will not be the last. Step back for a moment. Really step back. 1353 billion years ago, in a universe not yet 300 million years old, in a region of space that was just beginning to knit itself into structure, photons were born, forged in the violent furnaces of stars that no longer exist, in a galaxy that may itself no longer look anything like what we see. And those photons began traveling through a universe that was expanding around them, through gas and void, and the formation of other galaxies, and the births and deaths of billions of generations of stars, through the assembly of our own Milky Way, through the formation of our solar system, through the entire span of Earth's history, from its molten beginnings, through the first life, through the dinosaurs, through the entirety of human civilization, while those photons just kept traveling. They arrived at Earth in 2025. In April of that year, a telescope the size of a tennis court, drifting 1.5 million kilometers from the world that built it, pointed toward a specific patch of sky and opened its golden eye and caught them. After 1353 billion years of crossing an expanding universe, those photons landed on a detector built by human hands, in orbit around a human world, and revealed the ghost of a galaxy at the edge of all we can see. We didn't go to it. We couldn't. We sent no probe. We crossed no distance. We simply waited long enough and built something precise enough and pointed it carefully enough, and the universe delivered a message, written not in any language, but in light, in redshift, in the nitrogen signature of stars so extreme they may have existed only in the universe's very first hours, across a distance so vast that far away stops meaning anything, across a time so deep that everything that has ever mattered to anyone alive today, every war, every discovery, every love, every civilization, would not fill a single breath of it. The light found us. And for one brief, extraordinary moment, the most distant place in the known universe wasn't distant at all. It was right here,